Hello, and welcome to Absolute Automation Moments. I'm Mark Mashushin, Business Development with ARI, and this video will cover the 4 factors to implementing successful automation. The 4 factors will be split into 2 shorter videos. Let's dive into the first factor, freeing and loosening parts during ejection. Part ejection is critical when determining the complexity of your automation application. With standard part removal applications, the part and runner will freely eject from the mold. This means ejector mechanisms have moved the part to overcome high initial resistance. Then, parts can be moved with relatively little force. The parts are not fully ejected, but rather they're freed from the mold and still held in position by the core or cavity. As you can see in the graphic, there is a yellow translucent bar to represent a plastic part, which is being ejected by the ejector pins, and the end of arm tool is approaching to grip the part, while still held in the mold. From an engineering perspective, free ejection from the mold confirms there will be no special consideration with regards to payload. That means there are some special considerations to take when speccing a robot, which are as follows. Part and end of arm tool weight. As mentioned earlier, end of arm tooling and part weight must be factored into your project. Just because a robot's payload is 10 kilograms does not mean it can run safely with payload maxed out to its limitations. Next is part material. If you're molding a sticky material, parts can be more difficult to free from the mold. And ultimately, an unreliable part ejection can lead to more complex engineering of the automation and material processing. Moving on to the second factor, positioning the part after freeing. When dealing with positioning, we're looking for a consistent pick point on the parts. This means the gripper or vacuum circuit can repeatedly meet the plastic part for a successful grip, cycle after cycle. If parts are not ejected enough, they may require excess force. If parts are ejected too far from the mold, they can fall off before the robot is able to capture them. As a continuation to this topic, we will discuss ejector compensation and various options molders have when it comes to designing a consistent application. This will be in the video following the 4 factors. Next to come is the 3rd and 4th factors of successful automation implementation. Those are coordinating the robot and molding machine, and finally, is the application a stable process. Thank you very much for watching. Please do not hesitate to reach out for equipment, parts, or service quotation needs. We're still working as close to normal as possible and here to support our customers. If you have topic suggestions or questions, please reach out to me personally and check out the white paper download on our website. I will leave a link in the video description. Thank you very much and have a great day.